Okay, let's have a look at this problem here. This one's solving quadratic equations again, but this time we've got complex coefficients. We haven't got our nice real coefficients. So this starts to add a little bit extra to the extra difficulty to the problem. So really what we need to do is use quadratic formula. Forget about completing the square. Definitely forget about factorization. We're going straight with the quadratic formula. So we've got minus 1 minus 4i, so that becomes negative b, which becomes positive, plus or minus the square root. Okay, we've got the discriminant there, b squared minus 4 times a times c, so over the 2 times a. So expand that out, so multiply that out, multiply the minus 4 times the minus 5 gives you plus 20, minus 4 times minus I gives you minus 4i. Collect our terms, and that's minus 15 minus 8i is the expansion of that one. Comes down now to this situation. We've got the square root of 5 minus 12i. Now, our previous video we looked at how to find the square roots of a complex number. This is where we're going to use that. We're going to use this idea that we can find the square root of 5 minus 12i. A lot of times in exams when you see these problems presented, that would be part 1 of the question. This would be part 2 of the question. So they get you to do that, then put it in. So for this one, here's the solution here of x plus I y all squared 5 minus 12i. So we did what we did before. So expand the left hand side, equate our real parts and imaginary parts and do our substitution, get our quadratic equation and then factorize, ignore root solutions and give us complex values of x, and we just get x squared minus 9. So that's going to give us 3 on minus 3. Do our substitution in to minus 6 on x gives us 3 minus 2, minus 3, and y is equal to 2. So there's our 2 solutions. So 3 minus 2i minus 3 plus 2i. So when we write that, I can write it and realize that minus 3 plus 2i can be written as minus outside of 3 minus 2i. So this is why we write it like that, minus plus or minus 3 minus 2i, because it gives me those 2 solutions, which were the solutions given to us there. So split it up because we're going to have 2 separate solutions here. So 1 minus 4i plus 3 minus 2i. Again, collect our terms, our real parts, and collect our imaginary parts. 4 minus 6i on 2. 4 divides by 2 to give you 2. Minus 6 divides by 2 to give you minus 3. And then we have the 1 minus 3 gives us minus 2. Minus 4 minus minus 2 gives us a minus 2i. So, and then divide both sides by 2. There's our 2 solutions to that quadratic. Now that's a lot of work involved, because you've got to do a separate process of that to get the solutions to that square root of the quadratic. So that's where that part's definitely going to come in to solve equations like that. What we said before about appearing as complex conjugates, not occurring in this case because our coefficients are complex. That rule doesn't work here. It only works when we've got roots of the coefficients of our equations or polynomials, whatever we want to look at, being real numbers. Okay, so they are not going to occur in complex conjugate pairs. Makes life a little bit harder, but we can't do much about that. So there's our process there. We need to be able to solve quadratic equations with complex coefficients.